Okay, so I'm going to be doing number 21 from the chapter 5 homework. So this question basically gives us a bag of cement hanging from a ceiling in equilibrium by these two strings. And we know that equilibrium means that this bag of cement has no acceleration. And with that information, this question asks us to solve for this final equation, tension 1 equals to force of gravity times cosine theta 1 over sine theta 1 plus theta 2. So to solve this question, we're going to need to sum up the forces. We know that since this object is in equilibrium, the sum of all of its forces is going to equal 0. And we know also that we can split this force up into two directions, the x direction and the y direction, which will allow us to mathematically solve for this final equation. So if we take this one step further and sum up the forces in the x direction, and set the direction upwards is positive and right is also positive. If we sum up the forces in the x direction, we get negative t1 cosine theta 1 plus t2 cosine theta 2, which makes sense because if you look at this diagram, the only horizontal forces that are ultimately acting on this bag of cement are the horizontal components of these two strings right here. And again, because sum of forces equals 0, we know that we can set this equation equal to 0. In the y direction, we can do a similar thing. We know that the sum of the forces is going to be T3 plus or minus f of g, which is again going to be equal to 0. Okay, now we want to solve for T3 in order to simplify this y equation further. And we know that this tension in this rope right here is basically going to be equal to the vertical components of the tension in these two strings right here, which are going to equal tension 1 sine theta 1 plus tension 2 sine theta 2 minus f of g equals 0. So now we have basically the sum of the forces in the x direction and the sum of the forces in the y direction, which gives us a system which can allow us to solve for T2 in order to eliminate that parameter, which will allow us to achieve this final equation here. So just solving this system, if we take this sum of the forces in the x direction, negative t1 cosine theta 1 plus t2 cosine theta 2 equals 0. We can solve for t2, which will give us t1 cosine theta 1 over cosine theta 2, which gives us this expression, which we can plug into the sum of the forces in the y direction. So that gives us t1 sine theta 1 plus t1 cosine theta 1 times sine theta 2 over cosine theta 2 minus f of g equals 0. And now we can solve for t of 1, which we can do by distributing and getting t of 1 times sine theta 1 plus cosine theta 1 times, this simplifies down to tan theta 2, which if we move f of g to the other side equals f of g, and dividing the equation by this expression right here, t1 equals f of g over sine theta 1 plus cosine theta 1 tan theta 2. Okay, so I just noticed a mistake. This angle right here should not be theta 1, it should be cosine theta 2. So anyway, now we have an equation for T1, but if we look at the final equation, we notice that it's a little bit more simplified down. And right now, it might not be obvious how this equation can be simplified down into that, but notice that there's cosine theta 2 in the numerator. So the next logical step to take, or to try, I guess, would be to multiply both the numerator and the denominator by cosine theta 2 and see if we can use trig identities to somehow achieve that simplified form in the final equation. So doing that, we get t1 equals fg cosine theta 2 divided by sine theta 1 cosine theta 2 plus cosine theta 1. And if we multiply tan theta 2 by cosine theta 2, we can get sine theta 2. Now, Remember the trig identity, sine alpha plus or minus b equals sine alpha cosine beta plus or minus cosine alpha sine beta. And notice how this looks very similar to this that we have here. With that in mind, we can actually simplify this equation into this form here, which will give us what we ultimately want in the end. So then we have tension 1 equals force of gravity cosine theta 2 over sine theta 1 plus theta 2, which gives us our answer.